Nobody got any smarter. And yet the averages of both groups rose at the same time. Let's begin with the story of the laziest way to raise an average. There's a joke said to have come from Will Rogers, America's beloved comedian and cowboy philosopher. He said it about his home state of Oklahoma and its neighbor California. The joke's bar pricks both sides. Those who left were the ones dragging down Oklahoma's average. And at the same time, it means they were still better than California's average. But look closely and something feels off. All that happened is that people walked from one place to another. No one got any smarter, so how can the averages of both groups rise at the same time? The sense that the math doesn't add up, the sense of being tricked. Uncovering what that feeling really is, that's today's story. And this doesn't end as a barroom pun. In a moment, the very same trick walks straight into the survival statistics of a cancer ward. There's no scary math. All we'll do is add and divide a few scores, and move a few dots around in a picture. Let's set aside grand talk of intelligence and step into two classrooms, counting it out on our own fingers. At a certain school, there are two classes divided by exam scores. Now let's send the lowest score in the honors class, the student with 70, over to the regular class. No one retook the exam. Not a single student's score changed by even 1 point. Common sense says one side should rise and the other should fall. But when you count it out for yourself, both classes' averages rise. Let's confirm it with a picture. The top row is before the move, the bottom row after. The 70 outlined in yellow has come down from the top to the bottom. The honors class rose from an average of 85 to 90, and the regular class from 50 to 55. Both classes improved at once. Yet across the whole school, all 7 student scores are exactly as they were. So the overall average hasn't budged an inch from 70. The secret lies in the in-between standing of the student who moved, the one who scored 70. In the honors class, that student was the lowest score, the one dragging its average of 85 down. When he left, the honors class shed a burden. At the same time, in the regular class, that student is a high achiever, far above its average of 50. When he arrives, the regular class average rises too. The very same person was a liability where he left and an ace where he arrived. Take away just one sentence here. The averages rose not because anyone got better, but because the dividing line was redrawn. But moving just any student won't pull off this trick. There's a reason it had to be the 70. What if, instead of the 70, we had sent the top student, the one with 100, down to the regular class? The honors class loses its very best student, so its average falls. Conversely, if we put the regular class's lowest score, the 40, into honors, that student drags the honors average down. So to lift both averages at once, the score you move has to meet one demanding condition. It must be lower than the average of the class it leaves, and higher than the average of the class it joins. The trick works only when you move a student who fits through this narrow gate. Let's picture which candidates make it through. The yellow box is the in-between band where the trick works, exactly between the regular average of 50 and the honors average of 85. 70 sits neatly inside it, so moving it lifts both averages. But 45 is below even the regular average, so dropping it into the regular class cuts that average down. And 95 is above the honors average, so pulling it out of honors means losing a student you'd rather keep. Both fail the trick. This picture also explains why the joke's barb pricks both sides. To raise both states' averages, those who left had to be below Oklahoma's average and above California's. In other words, the joke quietly assumes Oklahoma's average was higher than California's to begin with. A fun historical footnote is in order. There is actually no record anywhere that Will Rogers ever made this joke. A joke in this form goes back at least to a 1939 newspaper column. It was about 2 counties in Mississippi, with no Oklahoma and no California in it. It took on the guise of Oklahoma and Will Rogers only around 1970, long after his death in 1935. Even this phenomenon's name was dedicated not to its true owner, but to whoever fit best. Even the attribution quietly migrated into a different box. So far it looks like a cute bit of wordplay with a score sheet. But when this redrawing of the line steps into medicine, something you can't laugh at happens. In fact, the very name Will Rogers phenomenon was born in medicine. In 1985, Alvin Feinstein, a clinical epidemiologist at Yale School of Medicine, and his colleagues published a paper in the prestigious New England Journal of Medicine. They put Will Rogers's name right in the title. The stage here is cancer staging. Cancer is graded from early stage to advanced according to how far it has spread. And by grouping patients of the same stage together, they compile statistics such as, the average survival time for early stage patients is so many months. But as time passed, precision imaging equipment like CT scanners improved. Tiny metastases that once would have gone undetected could now be pinpointed. Here is where the trouble starts. Some of the patients once classified as early stage had, in fact, been hiding a small metastasis somewhere in their bodies. Once the new equipment found that hidden metastasis, these patients were reclassified, no longer early stage but late stage. This is called stage migration. The cancer has not spread any further inside the body. The treatment has not changed either. The only thing that changed is a cell in the classification table, the boundary line. Doesn't this story sound familiar? Let's follow it through with a diagram. On the left is before reclassification. The survival times of the 5 early-stage patients are 96, 90, 84, 30, and 24 months. The average is 64.8 months. Among those 5 early-stage patients, the 2 outlined in red, 30 months and 24 months, are the ones whose hidden metastases the precision scan revealed. These 2 were among the worst off of all the early-stage patients. So once they dropped out of the early-stage group, the average survival of the early-stage patients leaps from 64.8 months to 90 months. At the same time, these 2 tend to live longer than the typical late-stage patients at 18, 12, and 6 months. So once they joined the late-stage group, the average for late-stage patients rose too, from 12 months to 18 months. Let's savor the result. The survival rate of the early-stage patients improved, and the survival rate of the late-stage patients improved too. Turn it into a newspaper headline and it becomes, "Cancer treatment advances at every stage." And yet the average survival across all 8 patients has not grown by a single day beyond 45 months. Not a single person lived any longer, and not a single person received any better treatment. 2 of them were simply rewritten into a different cell. In his paper, Feinstein pinpointed the heart of this trap with precision like this. And so, even though not one individual's outcome changed, the survival rate of each group goes up. This is an old hard problem, telling whether a new treatment truly worked, or whether the equipment simply improved and the boundary line was redrawn. That is why this phenomenon makes it dangerous to naively compare cancer statistics from 2 different eras. If you want to place the late-stage survival rate of 1980 beside that of 2020 and declare that treatment has advanced, you first have to reckon with how many patients the diagnostic equipment quietly rewrote into a different cell in between. This trick shows up anywhere there is a classification table and an average being taken. First, when the diagnostic criteria change. Suppose we lower the diagnostic threshold for high blood pressure or diabetes. Those right at the border, normal until yesterday, are, as of today, classified as patients. Within the normal group, these people were the least healthy. Within the existing patient group, they are the healthiest. As a result, the healthy look healthier, and the patients look healthier than patients used to. And yet no one's actual health has changed at all. Second, the averages of teams and schools. Send a middling performer off to another department, and the average of the department that sent them can rise, and so can the average of the one that received them, as long as the receiving side's average was lower. So when a report lands on your desk saying both sides improved, it's worth pausing to ask whether anyone actually got better. Third, whenever you meet the word average, the Will Rogers phenomenon has a few statistical cousins. Simpson's paradox, where every part points one way but the whole flips the other, and regression to the mean, where an extreme drifts back toward ordinary the next time around. All 3 share one thing. A single number, the average, hides what's really going on inside. An average is a wonderfully convenient summary, but it never tells you who moved into which box or out of it behind the scenes. So whenever you hear that some group's average has improved, there's one question you should learn to ask first. What we did today in the end was repeat a single move 3 times. The lowest score in the honors class into the regular class, an Oklahoman into California, a patient with a hidden metastasis from early stage into late stage. Move a single element from one box to another, and the averages of both the box it left and the box it entered rise at the same time. It happens because that one element was below average in the box it left, and above average in the box it entered. The lesson to take from this is light but solid. A rising average does not mean anyone inside it got better. Sometimes an average shifts even though no one has changed at all, for the sole reason that a line was redrawn. The reason Will Rogers's joke is funny, and the reason Feinstein's warning carries such weight, are one and the same, and they live right here. So the next time you come across a welcome statistic saying an average has improved, before you applaud, think of Will Rogers and ask this: could it be that someone simply walked from one side to the other? If you enjoyed today's story, subscribe, hit like and turn on notifications, and I'll see you again in the next one.